Okay, this should be the last one. So I wrote my program, got the part. This is operation 1. Remember, we're going to have that cap on the bottom. We're going to have to turn the part over, figure out a way to hold it. We're going to either hold it by the big part or the island, which will kind of affect where your zero is going to be. But in this case, we're only face milling the back, but I would get in the habit of locating your operation 2 correctly, because now you have to locate off the part, and it's going to have overhanging material on it. So myself, I choose to use like a 1, 2, 3 block to put in the machine if I'm edge finding or probing. I'm going to capture those 2 planes. Like if this is the 0, 0 up here and you flipped it over 180 degrees, then if I'm on this one, the fixed jaw becomes Y0. We're not dealing with the stock. Do not edge find the stock. That is not important on operation 2. You got to be lined up to the material, so everything lines up. You don't get holes that don't line up. And I think in this exercise I had everybody countersink the other side, and that told you right away if you were lined up or not, because these are through holes. Ooh, wait a minute. And that reminds me, my G83 cycle, I just thought about this. That's not deep enough. I have to go through this thing. So I got to go 750. I don't have my Haas book with me, so I got to go at least 750. And I'm going to say we're using 1-inch thick material. I'll go to like 0.95. That should be through, and I'm not going to hit anything underneath. But these are things you could fix. That would be a not bad mistake. You'd be like, oh, that didn't drill. Oh, and you edit the program, and that'll be it. But remember, the gold will be in the machine. If you intend on saving programs, you want to save the one in the machine, because you may make some edits. So. All right, let's hit a file save here. File save. Okay, I'm going to use the NC Viewer. This is online tester. I have my Haas simulator back there, but it's hard to see. I wish I could put it on the computer screen. Okay. Let's see. He wants to know where the program is. I stuck it on the desktop, and we called it 5678. Hit open. Ooh, look at that. There's already a program there. I think there's some issues. Let me look at the top view. Oh, yeah. Okay. Well, there it is right there. I even have a digital readout here. Okay. Let's just hit the play button. I think it runs kind of fast, though. Yeah, it's kind of too fast. All right. Let me put it up here. Let me go back to ISO view. Let's look at what the heck is going on here. We'll go step by step. I think this is step by step. 1, 2, 3, 4, 5. Of course, it's not going to show the tools by size, because this isn't doing that. It's just going point to point. All right, that's the move for the face mill. That looks okay. And then it comes down and goes across. I think this is not going to the right far enough. See, we need it to go way over here. So I could tell that's not correct. Oh, I could see my issue right away. It should have been, I should have added that number to, let's go to the print, this 3 right up there. So in this program, way up here, there it is right there. So that should have been 4.7. All right, fix number 1. Hey, I don't plan these mistakes, but good learning lesson. Okay. All right, what's the next step here? Tool 2. All right, tool 2 starts up there. Cut a comp on, ink, go to the right, go down, square, square. That looks good, and that's compensation off. The last move, and it wraps up, goes to a new position, just to look, goes down, and this is cut a comp on. It looks good. Goes to the beginning of the arc. Does an arc move? Does a line? Does a arc? A line and oh, it's what's the next line do? I don't know if the charts. I can see right now I don't have a Y negative. Let's fix the code. That was tool 2. Where the heck is tool 2? Right here. Let me just put a space. Right here. That would have been the second time around, the second D2, and it's right here. Should have been a negative. Negative. Oh, the other one's negative. Yes, they are. File, save. Okay, let's continue on. Okay. I think the rest of it's right. Now I'm going to do the little zigzag move. So that should just go back and forth, back and forth, back and forth. That looks okay. And then I'm going to do the drills. That's drill 1, drill 2, drill 3. And drill 1, drill 2, drill 3. Okay. Let's put in a new program here. Open. Okay. Almost. Why is it something's missing there? Something is missing. Actually better if I look at this one. Oh, what happened to my program? Open this one. Open. Okay. T2. There it is. No, wait a minute. That's correct. X.25. Oh, that's G3 is this way. X, G2. Right. Unless it doesn't recognize that. It should. File save. File reload. Of course, if you're in the real machine, you could just run it from there. All right, let's start from the beginning again. Still seems to have an issue. Maybe it's not showing up. So, I think we're missing something there. Ooh. All right, let's go line by line again. Okay, go to face mill position 1, come down, go across, and then go get the end mill position. There, go around, round. That's done. And go to second level, there, arc, line, arc. I don't think it showed it. I don't know why it didn't. All right. And see the zigzag moves there. See right there? Zigzagging down. Okay, and it's going to go to drill the holes. Yeah, drill 1, 2, 3, and then do the peck drilling 1, 2, 3. Okay. All right, that's simulator number 1. Let's call up the Simco right here. Simco. This actually comes with the Mastercam. Let's open that file up. They gave some sample ones in here. This PC. Where's my desktop? I'm lost already. Let's see. Oh, there it is, desktop. It's looking for NC files. That's why it's not seeing it. I'm going to say look for text files. There it is, 5, 6, 7, 8. There's the program. The Simco edit is nice because it's really meant for G-code stuff, and it actually subdivides everything by color. And you can do things like add line numbers, renumbering, remove line numbers, remove empty spaces if you're trying to save size. But I think we're okay like this. And you can do Shift Control P. My buddy Mike Ware showed me that one to do simulations. And whoa, I can see what our problem was right here. All right, let's run this simulation. So I'm going to rewind it up to here. I got some X and Z coordinates. This is my play button. All right. That would have been the face mill. Then we go get the end mill. A little bit better simulation. Yeah, something goes wrong, wacky there. Zigzag down and 1, 2, 3, and drill a bit deeper. Obviously, you can see what it's doing there. Okay. In this case, let's see. Let's go back here. We can edit right inside this T2. Right there. Oh, it even goes point to point. Why did it go up? It says Y 1.0. I don't see any Z in there. What is going on? G02 and then Y 1.0. Let me just retype it. Maybe it just got weird. Y 1.00. Enter. Nope, that didn't seem to fix it. Let me eliminate that one. Eliminate that one. Now it's Z0. Okay. Okay, G0. Oh, maybe I didn't go. Oh, I didn't put G01 in. Oh. 1.0. Yes, that's it. Cut a cop off. That's G40. And X, what was it? Minus 1.5. There we go. There we go. All right, let's rewind. Start up here. Okay. Play. Face mill. End mill. End mill up a little higher. Beautiful. Zigzaggy slot mill. Yep. And spot drill and deep hole pecker. One. Now remember, in simulation, you're not going to see everything. You're not going to see everything like if I'm using the machine simulation, you only got to get a top view of it. But I make it as standard that even if I'm doing a fusion program or a Mastercam program, I'm going to run the simulation as part of my prove out process. Any alarms might come up if I see anything weird. You know, you can only learn so much. And then, if you have the time, we'll do a dry run in the air. We'll shift the Z offset up 2 inches, run it in the air, covering the feed hold button, just in case, and see if there's any noticeable issues. If that is okay, then we're going to go bring the Z back down to where we want it. And we're going to run every tool with the optional stop on, because that's what the M1 code is in there for. That's so we can optionally stop. Now, if you're setting up, you want to run, take a look, do next tool, run, take a look, make sure every tool is doing its job. Or if you're in production and you need to go somewhere and you don't want it to continue on, you turn the optional stop switch on and it'll just be waiting for you when you get back. So that would probably be the 2 most common reasons why to do that, but you always want to have an M1 in your code. The other one's called M00, and that's called a program stop, which means if you intend on doing something and you really need to give a comment in there, like flip part or clean off chips off drill or something like that. But that's pretty much nuts and bolts of G code here. I'm going to put up my, not much more I can say on that other than, what do we do with these? Now you're gonna have to, when you get some experience, you'd say, oh, I don't think my end mill is gonna be able to cut everywhere. Other than using a bigger end mill, you would have to guesstimate where these are. And I would just go and run simple G1 moves with no compensation over the corners. Or you can kind of just stay on the outside and make like a square. That would be an easy way of doing it. Another trick I use if I want to use rough and finish, and it's an example in the Haas workbook, is take the same exact contour and tell your tool that it's a little bit bigger. So you tell your half-inch tool you're like 0.520 diameter, not 0.500, and that'll be your roughing move, and then you have your finishing move. You can also use it for chamfering. You could just use the same contour, same program, only I call it the 50-50 method. The Z minus will be 50 thousandths down, and you put 50 thousandths as a radial offset, and if you're ever in diameter offset, you make it 0.1. So at the edge of the tool would just barely skim around the contour. So in this case, you'd be Z0 up top, and down here be 0.3, so you'd be like 350 deep, and you'd be compensating around. So that's a nice little quick trip. And then this one, you'd have to get a little inventive on that one because we had slotted down the middle, so we didn't contour that one. And if you had issues with the slot not coming out great, you'd have to use a smaller tool, like the next size down would probably be 3/16, 1/87.5, and you could zigzag your way down the same way, and when you get down the bottom, you're gonna go feed to the wall and loop around. That's about it. That'd be probably the best way to do that. All right, thanks, and enjoy your G code. Don't fear the G code.